For countless generations, people have stared at the vast expanse of the nighttime sky, driven by curiosity about the innumerable unsolved mysteries of the cosmos. Throughout the 20th century, scientists unveiled the Big Bang Theory, which sought to explain the inception, development, and enlargement of the universe. However, despite widespread acceptance, this hypothesis still lacks in resolving some of the most profound inquiries surrounding the cosmos. In recent times, revolutionary discoveries have introduced additional layers of intricacy to these astronomical riddles. For example, in 2023, NASA's James Webb Space Telescope made an extraordinary find. It spotted celestial formations that appear to be more ancient than the universe itself. This incredible finding has puzzled researchers and sparked debates on whether stars might genuinely persist for a span surpassing the presently acknowledged age of the universe. This kind of contradiction undermines our current scientific paradigms. Might this disparity imply the demand for a completely new cosmological theory? Roughly 200 light-years from Earth, within the Aeson-Lee constellation, there exists a star named HD 114283. What distinguishes this star is its remarkable velocity, moving at 44.83 kilometers per second, providing important insights into its turbulent origin. Around 1 billion years ago, during the early formation of the Milky Way, it collided with a smaller satellite galaxy, which gave birth to this specific star. Nevertheless, HD 114283's most extraordinary feature is not its motion but its age. This star is one of the oldest known stellar objects ever observed, earning the nickname Methuselah, after the biblical figure reputed to have lived 969 years. Initial age estimations placed it at an astonishing 16 billion years, though more precise assessments have revised that to 14.46 billion years, with a margin of uncertainty of approximately 800 million years. This variation raises a major puzzle when compared with the current approximation of the universe's age, about 13.8 billion years, according to data from the cosmic microwave background radiation. This gives rise to an essential: this notion contradicts our present-day scientific comprehension. Consequently, scientists have started to reassess the accuracy of our instruments and techniques used to determine the ages of both stars and the universe, urging further examination of these cosmic puzzles. To appreciate the scale of this issue, it's crucial to recognize the complexities involved in determining stellar ages. Stars like our Sun maintain relatively consistent temperatures and sizes for billions of years, making it especially hard to determine their ages precisely. Astronomers analyze minor changes in a star's luminosity and hue and compare these observations to theoretical models of stellar evolution. A key parameter for estimating a star's age is its rate of rotation. Just like a spinning wheel decelerates over time due to friction, stars slowly decrease their rotational speed. By evaluating the spin of stars at various stages, scientists have devised mathematical strategies to estimate a star's age, a method known as gyrochronology. Methuselah, the focal star in this discussion, is undeniably ancient. Existing observations propose it may be the oldest star ever detected. Rather than focusing solely on whether it exceeds the universe's age by over 2 billion years, we might instead contemplate: is it conceivable that the universe itself is older than we believe? Comprehending what 13.8 billion years signifies is no simple task. If we compress the universe's timeline into 1 year, with the Big Bang on January 1st, planet Earth wouldn't appear until the last seconds of December 31st, and human civilization would last just a few instants. Experts calculate the age of the universe by examining light from distant celestial bodies that formed hundreds of millions of years after the Big Bang. As the universe continues expanding, this causes a phenomenon known as redshift. By measuring both the distances of objects and how fast they are moving away, scientists have estimated the age of the cosmos to be roughly 13.8 billion years. Still, new research from the University of Ottawa suggests a vastly older universe, possibly as old as 26.7 billion years. Dr. Rajendra Gupta, a physicist at the university, offered a theory combining Swiss astronomer Fritz Zwicky's 1929 idea with modern physics. His proposal states that protons may lose energy over extensive time and distance, challenging the conventional view of redshift. According to Gupta, redshift might result from a combination of effects, not merely cosmic expansion. This alternative interpretation might produce a much older estimate for the universe's age and could help solve long-standing astronomical dilemmas, particularly those emphasized by NASA's recent observations. Gupta's model builds upon the tired light hypothesis and ideas from theoretical physicist Paul Dirac, who proposed that fundamental forces in the universe may have changed over time. It's essential to note that our understanding of the universe's age has evolved significantly. In the 1920s, Edwin Hubble believed the universe was only 2 billion years old. Later findings dramatically increased this number, eventually landing at the contemporary consensus of 13.8 billion years. Whether we see human history as lasting 10 seconds or 5 seconds in the grand cosmic scale, one truth remains: the universe is unimaginably ancient. Its ongoing growth keeps challenging past assumptions about its beginnings. Meanwhile, new findings about our Milky Way galaxy are prompting fresh debates. Evidence now indicates that stars on the galaxy's edge travel much more slowly than stars in other galaxies. Several hypotheses have been proposed. One idea is that our galaxy might contain an unusually low amount of dark matter, an invisible substance thought to account for most of the gravitational forces in space. Alternatively, our understanding of dark matter itself and its distribution might be fundamentally incorrect. This doubt arises from data collected by the European Space Agency's Gaia mission, which has mapped the positions of nearly 2 billion stars in the Milky Way. The results have led scientists to re-evaluate their models of stellar motion, especially in the galaxy's outskirts. The orbital speed of stars is essential to computing a galaxy's total mass, since gravity is directly linked to mass. A new study based on Gaia's information calculates the Milky Way's mass, including gas, dust, stars, and dark matter, to be around 200 trillion times the mass of our Sun, which is 5 times lower than older estimates. This drop may reflect a decrease in observable material, possibly hinting at reduced dark matter. However, calculating a galaxy's mass is highly complex, and inconsistencies may stem from either the satellite data or the analysis techniques employed. As more revelations emerge, we'll continue to monitor these breakthroughs. Over the next few years, advances in technology and upcoming space missions are expected to yield deeper insights into these celestial dilemmas. Thanks to its unparalleled capabilities, the James Webb Space Telescope will keep expanding our boundaries of cosmic knowledge. We're not just examining the age of stars or the universe, we're also attempting to decode the complex dynamics of galaxies, dark matter, and the forces steering cosmic change. Understanding the universe's expansion remains a central topic in astronomy. But as our knowledge base grows, we might find that earlier conclusions were limited or even inaccurate. One significant query is whether the laws of physics we currently trust apply uniformly across time and space. Could undiscovered influences or unknown phenomena be affecting how galaxies move or how stars evolve? As our instruments grow more advanced, we may discover new cosmic components that challenge even our most well-established theories. An increasing number of researchers acknowledge that our knowledge of dark matter, dark energy, and basic forces is still incomplete. Every new discovery, from remote galaxies to ancient stellar relics, provides insights while also bringing stretching the boundaries of what we scientifically comprehend. The idea that stars may predate the universe, or that the universe might be far older than our models suggest, calls for a complete re-evaluation of how we approach cosmology. It may demand new physics, innovative theories, or even radical ways to understand time and space. These changes also provoke profound philosophical about our existence and our role in the universe. If proven true, such discoveries wouldn't merely revise science, they could revolutionize our entire view of reality. As the debate about the true age of the universe continues, one thing is unmistakable: we are on the brink of a pivotal era in astronomy. The coming decades may yield answers to riddles that have puzzled humanity for millennia. Whether we're investigating ancient stars or exploring the mysterious forces of dark matter and energy, the universe still holds countless secrets waiting to be unveiled. The road ahead is one of exploration, learning, and constant rethinking of what we think we understand. Although the solutions may still be out of reach, the thrill of exploration is only beginning. The James Webb Space Telescope, with its cutting-edge imaging technology, is set to be a key player in decoding cosmic secrets. It has already revealed remarkable new findings about faraway galaxies, distant planets, and other astronomical phenomena, but its mission has just started. As Webb explores further into the cosmos, it could uncover insights that redefine our fundamental perception of the universe.